Okay, guys. So yesterday we have completed few topics from our dynamic routing, which was our RIP version 1 and RIP version 2. So in this, we have completed till up to, you can say that the configuration of RIP version 1, and we did this configuration. Okay, and we checked the configuration status with the so commands, and we verified the RIP version 1 process and its broadcast address, which is used to communicate between RIP routers. Like if RIP1 router wants to communicate and share the informations with RIP router 2, so how they are going to exchange the information between them. So normally RIP version 1 use broadcast address, which is 255.255.255. Okay, and we verified RIP version 2 also, and we saw some the need why we need to configure RIP version 2. We have seen that whenever we are configuring some RIP routing with subnetted networks, and if we are using RIP version 1, so RIP version 1 won't support the subnetted, or you can say classless network routing. That's why we need to configure RIP routing version 2. Okay, so we have seen how to configure RIP routing. Okay, we have configured router RIP version 2. So the difference between the command of RIP version 1 is that in RIP version 1 configuration, we do not define RIP version, and we do not configure this one. No auto, what is the meaning of no auto? See, what is the meaning of no auto? The no auto command, okay, will prevent the router 1 from summarizing this network 10.1, okay, 00 network. Okay, instead router 1 will send update including like 10.100. Okay, and the subnet mask will be this one. So like if you will use this command no auto, means please do not summarize my network as default, because right now here you are using 10.1.0.0/16, means you belong to class A, but you're using the subnet of class B, so it is subnetted IP, right? Okay, so here I am saying that no auto means when router 1 will advertise this information to router 2 that yes, I have one network which is 10.1, okay, and I want to share that network with you. So router 1 will advertise with router 2 as the subnet of like this /16 like that, okay. But if we are talking about RIP version 1, so RIP version 1 will summarize automatically, because or there will be auto summary enable in RIP version 1, so it will summarize like this, okay, and you will find it that instead of 10.0.0.0, okay, it will be like 8. Okay, so yesterday we have seen that RIP version 1 summarize the IP address to its default subnet or default mask, you can say. Like if you are using 10 network, right, so it will be like 10.0.0. Okay, if you are using any kind of subnet, so normally if I'm using subnetted IP, it will summarize to default one, simple. Now you can see here what is the use of auto summary. So as I told you, auto summary in RIP is to restore the default behavior of automatic summarization of subnet routes into a network level route. Okay, means if auto summary is there, means it will summarize automatically to the default. If I'm using some network like this, maybe I have one router here, maybe I have one router here. Okay, and to this router you have like two interface. Okay, one is WAN interface and one is LAN interface. So maybe if I'm using this subnet, sometimes we use like this /30, and here we are using some subnet which is 192.168.10.0/28. Okay, now when this router is connected with other router in the network, the neighbor router you can say, and when this router is advertising the information to router 2, this information when it is connected, okay, so router 1, which is here R1, will send update to R2. So the update, like suppose if you are using RIP version 1, okay, so when the update is coming to this update what we are talking here, so this 12 and this, when this 2 update is coming here to this router interface, that okay, yes, you have received these 2 information from your neighbor router 1, so router 2 will create one routing table, right, on behalf of the information what he is receiving from router 1. So what type of information router 2 is receiving? See, because RIP version 1 do not support summarization, so RIP version 1 router will send the information to router 2, like it will convert 12.112 like this, okay, and it will convert this one to 192.168.10.0/24, okay, and this 2 information will come to router 1, router 2, and router 2 will keep these 2 information in his routing table. Okay, now for example, if there are some kind of networks, it's a subnetted network, this is your switch, something like that. Okay, maybe if your router 2 is also connected with some networks, okay, and maybe your router 2 is also using some kind of subnetted networks which is 192.168.10.0/27. Okay, see, normally if you will check technically, the both network is different. 192.168.10.0 is different, and 192.168.10.0/27 and 28 is totally different. Okay, but if you are using RIP1 will advertise this as a default. So now what will happen? Router 2 will not accept this network from router 1. Router 2 will say that I can accept your 12, okay, but I cannot accept 192.168.10.0 because I have already 192.168.10.0/24, and it is locally connected. But in a real condition, it is like that. Okay, because when router 1 is sending updates to router 2, it will send default. It will summarize the subnetted network to default. Same router 2 will send router 1 the connected network information, so it will remove the subnetted information, it will share the default information with the router 1. But if like this network will, means you can say that network never runs with the full default IP address. So every network, every companies, they use subnetted IP, right? That's why RIP1 is not in use. We use RIP2, and we use this command to no auto summary command, okay, to stop auto summarization simply, okay, to disable auto summarization. Okay, so I should show you about this auto summarization and no auto summarization effects. So let's come to our GNS. Okay, so in GNS3, let's maybe suppose this is our router 1. Yeah, I'm just for example, like, okay, so start this router and take a console. Okay, so suppose I want to configure RIP1. So let's come here, type here router RIP just to check about auto summarization. Okay, and I'm just enabling RIP1 network. Okay, so I have enabled RIP1 simply. Okay, and if I'm using one command, so IP protocol, so you can see here automatic network summarization is in effect, means there will be automatic summarization, means whatever network you are adding, and those networks are subnetted networks, so automatically those subnetted networks will be summarized to default networks. Like if you are configuring 10 networks, so 10 belongs to class A, so automatically that 10 will be there with default class. Okay, so it doesn't matter that you are using 10.1.10.10 slash 0 slash 24. Okay, if you're configuring like this, right, but it will be summarized, and it will be see, on router 1 it will be like that, but when router 1 will advertise this information through RIP, so it will advertise like that slash it. This will be the problem. And why this will be a problem? See, normally we are doing lab with one router or two router, but you can understand if some routers, if in the network, maybe if you will have like multiple routers, right? Okay, so if maybe router 10 is using this network, it's totally different network, 20 something like that. Okay, router 3 is using this 40. Okay, and router 2 is using this as a 30 something like that. Okay, so it will never work like that. Okay, 20, 30, 40 like that. Okay, why? Because when this router 1 is advertising this information, this network information to maybe like when R2 wants to advertise this information to R1, so even the information will come like this. R1 will say, no, I cannot accept this one because i'm 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 also advertising the same information, means I have that information what you are giving to me, so router 1 will not accept. When router 2 is sending to this one, R4 will say that yes, I have that same information. R3 will also say that I have same information. Okay, so it will never works. Okay, why? Because the automatic summarization is there. So what is the, now we have solution to use RIP version 2, and RIP version 2 have option to disable auto summarization. So if we are coming here in our scenario, and when we are coming to router 1 and we are coming here router RIP version 2, once you are enabling version 2, and if you are checking here do so IP route, you can see here, okay, router RIP version 2 network exit, so IP protocol. Now you can see here automatic network summarization is in effect, but RIP version 2 is running fine. Is not in effect, it should be written like that. Okay, okay, sorry, I have never router RIP version 2, okay, network 00 like that, and here if I forget to write no auto summary. Okay, and then you exit, and then you write that command show IP protocols, and now you can see here automatic network summarization is not in effect. But if you see the previous one, when RIP version 1 was running, okay, at that time you can see here automatic network summarization is in effect. Okay, so when you will enable RIP 2, you know the benefits. Now routers will be advertising the network what they have, like, okay, so it's totally different. So every router will exchange the information like that. Okay, every router will accept because the information what they are exchanging is totally different network. Okay, so now here this is VLSM. VLSM is known as variable length subnet mask. So this is totally related to subnetting. Okay, so maybe I'm using this. If you have joined my subnetting class, you know the subnetted networks. So if this is your default networks, okay, but you want to share this default networks with multiple uh, organizations. So in the subnetting, like suppose if you are using class C kind of network, okay, so in class C, that you can see here that this is your network 192.168.10.0/24, and in this 10.0/24 you will have 255 host, or you can say 255 IP addresses. Now you want to share these all 255, or you want to break this 255 large network into a small networks. Okay, so now you have to share this with another organization with 60 host, 30 host, and 12 host, right? So this is known as VLSN. Okay, see, subnetting is what's okay. Subnetting is normally it is known as FLSN. Okay, full length subnet mask. Full length subnet mask means when we normally do subnetting, so when we divide, so the division is equal, right? If I have 4 subnets after breaking this large network, so here also it will be 64 IP, here also 64 IP, here also 64 IP, and here also 64 IP. That comes under FLSM. And VLSM is saying that variable length subnet mask means router means company A need different in IP, company B need different IP need, company C has a different IP need. Okay, so that is VLSM. Okay, so we have here one Vlsn Lab. Okay, so let's see how to configure this Vlsn Lab. Okay, so you can say that we can say here RIP version 2 Vlsn Lab 1 Lab 1. So let's take 3 routers here. So we are taking 3 routers. Router 1, router 2, router 3 as per scenario, and we have to take one switch, Ethernet switch, and then we have to take some PCs. So let's take VPCs. So let me design the network scenario. So here we are using switch, so I'll use switch. Okay, fine. Switch is switch 1. Okay, router 1, router 2, router 3. Okay. And PC1 change symbol So this is our PC1. Now we can make a duplicate of this. So now we have two PCs per network. Duplicate. This is for this PC3, PC4. Fine. Again, we can make duplicate for this switch 3, PC5, PC6. We can align them to be proper. Okay, fine. Now it's part of connectivity. So connectivity, you already know that PC to switch we can use Ethernet cables. Okay, and switch to router we have to use Ethernet cable. But router to router you have flexibility that you can use Ethernet or serial, right? So here router 1 to router 2, router 2 to router 3. Enable the ports. This is important. Port number. Okay. So now here uh, router 1 to router 2 we are using 12.1.1.0/30 network, and here we are using 23.1.1.0. Here the LAN, you can see the LAN segment of this network is your segment. So here in this LAN segment you are using 192.168.10.0/26. So if you use this one, you will, means like the requirement was LAN segment requirement need is 64 or 60 host, you can say 60 host. So if you need 60 hosts and if you have done subnetting, you know that you need this 10.0/26, this subnet. Now here we need 30 host. So for 30 host, okay, we have to use like this 10.0/64/27, and here we need 12 host. 12. So for 12 host we have to use 96/28, 96/28. Fine, you can write here Vlsn Lab 1 RIP version 2, because these all subnetting network you cannot perform through RIP version 1. Okay, because RIP version 1 supports class full network, but here we are using subnetted. Okay, so that's why it is class less network. Okay, so normally these all separation of IP addresses are from class C 192.168.10.0/24. Okay, so here we have to define some IP address as a gateway of this network. So we can say that okay, 110.10 will be the gateway here. Okay, here we can say that 192.168.100 will be the gateway, and here we can say that the gateway will be like 192.168.10.70. 10.70. Okay, fine, your lab is ready now. Now we can configure. So for configuring we have to start all the labs first. It's all the routers. After starting, then we have to take a console of the devices, console access. Okay, so welcome to PC1, and we have to configure PC1. So PC1 IP is very simple: 192.168.10.1/26, and gateway is 10.10. PC2 IP 192.168.10.2/26, and then gateway is 10.10. Okay, so we could save these all configuration, save to PC1. Okay, we have saved. Now let's come to R1. So R1 has two interface. So let's come here, conf t interface serial2/0 IP address 12.1.1.1 255.255.255.252. Okay, and no shut. Now you can move to your interface. Interface E0/0 IP address is 192.168.10.10, and the subnet mask is, if it is 26, so subnet mask is 255.255.255.192. Okay, no shut. I think I did some mistake on PC1. Okay, no, PC1, PC2, fine. R1 is also okay. If you want to verify, so IP interface brief exclude unassign. Yes, IP is configured. Okay, now we are going to move to router 2. Same here, come to conft interface serial 2/0 IP address s12.1.1.2 no shut, then come here interface serial 2/1 IP address no shut, then come here to interface E0/0 IP address is 192.168.10 dot what we have decided here 10.70. Okay, fine, 10.70, and subnet mask is 255.255.255, and when it is /27 it is 224 no shut. Okay, so you can save the configuration of R1 R2. Now you can move to PC number 3. PC number 3 IP is 192.168.10.65/27, and gateway is 10.70. Save. Now come to PC4 IP 192.168.10.66/27, and the gateway is 10.70. Save. Now if you are coming to R3, router number 3. Router number 3 has two interface. So I'll come here conft interface serial 2/1 IP address 23.1.1.2 no shut, and then interface E0/0 IP address 10.100, subnet mask is 240 no shut. Fine. Okay, save the configuration. Now let's come to R1 R2 and verify. So IP interface brief. Okay, fine, IP is okay. So IP interface brief, exclude unassign. Okay, fine, configuration is okay. Now we have to configure your PC5 and PC6, the last one. So IP 192.168.10.97/28, and the gateway is 100. You can save the configuration. Now come to 698. Save. So IP configuration is completed. Okay, once the IP configuration is completed, same if PC1 wants to communicate. Okay, so it will try this command ping 192.168.10.97. maybe it wants to communicate to PC6. No communication, destination host unreachable, so you have to come to R1, you have to configure the network routing. Okay, before configuring routing, if you are checking here, so IP route. So normally R1 will get only two information which is directly connected. So 12 is directly connected network and 192.168.10.0/26 is directly connected network, right? So now you can say that okay, no problem, let me come here and configure RIP version 2. So conf t route router RIP version 2 network. So here you have to advertise your directly connected networks. So you have two directly connected networks. One is this one and second one is 192.168.10.0 no auto summary exit. So router 1 configuration is completed. Now come to router 2. Conf t router RIP version 2 network 12.1.1.0 network 23. Okay, three networks are connected to router 2. You can see here one is 12, second one is 23, and third one is 192.168.10.64/27. Okay, that is subnetted network 192.168.10.64, and then you have to write here no auto summary exit. Now you come here to your router 3, same router RIP version 2 network 192.168.10.96, and second network is 23.1.1.0 no. Once the configuration is completed, now you have to come to art1 and verify. So IP route RIP. Okay, yes, now your router 1 is receiving updates from router 3 and router 2 with the help of RIP protocol. Okay, see, if you check this command, router command, so here with this router, so IP route command, what you can see, all connected networks plus your received RIP network. Okay, so whatever network you are receiving, so see, this is your connected network and this is your connected network, but this 23 10 64, okay, this 10 26, okay, this is 10 64. Okay, so these all networks you are receiving from neighbor, right? One more network is, okay, see, now you receive this 96 also from R3. Okay, now once everything is updated, and in the beginning of class we came to know that RIP is the RIP has slowest convergence, that's why RIP is taking time. But if you will start learning EIGRP and OSPF, the convergence are very faster. So now you can see that yes, they are communicating. So this how RIP works. Okay, but now as I told you that when I came to router 1, okay, you have seen that router 1 was getting all the updates like this, right, from here to here, but it took some time to get update from router 3 about this network. So why they are taking time? So what type of timers they are using? So we are going to know about some timers. Okay, okay, so let's know about timers. So this lab is completed. Okay, see here, this Okay, /26 /27 /28. Okay, now we are talking about RIP timers. So normally RIP have 4 timers. Okay, one is update timer, which is 30 seconds. Okay, and this is periodic. Invalid is there, hold timer is there, and flush timer is there. So let's understand these all timers. Okay, first of all, let's verify those timers. So if I'm coming on RIP1, okay, so on RIP1 you have to type so IP protocol. Okay, so when you will type so IP protocol, you will see some informations here regarding timer. Okay, sending update 30 seconds, invalid timer 180 seconds, hold timer 180 seconds, flush is 240 seconds. Okay, now how these all timers work. So if you are talking about this sending update in every 30 seconds, so this is known as update timer, not hello timer. Okay, hello is different, update is different. Update is that router 1 is exchanging update information, like routing informations in the update packet in every 30 seconds, and update, and that is periodic. In every 30 seconds router 1 will share the routing information to router 2, and router 2 will share the routing information to router 3. Okay, now invalid after 180 seconds and hold down time after 180 seconds. Okay, so these both timer, this 180 seconds means this 3 minute, invalid and hold is same, they run together. Okay, so invalid means if router 1, okay, or router 2, if router 2, maybe if router 2 is, maybe this link is down. Okay, is 0 by 0, this link is down. So router 2 will say that to router 1 that please, this network, this 192.168.64/27 is down due to some reason. Okay, so R1, if you are coming here, R1 routing table, so R1 will remove that network from its routing table. Okay, or make that network which is already there in the routing table of R1, right, make it invalid after 180 seconds. Invalid means, I can say, like talk about here R2 and R3. Maybe R3 came here. Okay, okay. Let's enable some kind of debugging to know that one. Debug IP RIP, come here to R2, debug IP RIP, and R3, debug IP RIP. Now debugging is running. Let me explain you. See, normally this network, what we have here, 192.168.10.96. So this network will be advertised via R3, okay, to R1, right? And R1 will advertise this all network which received plus connected network to R1, and R1 will get informations like that, right? Now what will happen if this network R3 is sending to R1, sorry, R2, and what will happen if this link is down, is 0 by 0 is down, right? So for R3 this network is invalid, right? This network is down, but R2 will keep this network in his routing table, right, for last 30 seconds, right? And R2 will send this information to R1 as well, right? So what will happen, the invalid timer helps to tell R2 that please, about this network, that when router 3 is sending some updates to router 2, it will not include this network. So R2 will ask from R3 that what happened, you initially in that starting time you have sent me about this network, right, the information for this network, but now you are not sending. Okay, so R2 will wait for this network to its routing table for 180 seconds, and after 180 seconds R2 will say that yes, that network is invalid. So when the R2 will say that that network is invalid, it will inform to R1 as well. Okay, and hold down timer and invalid is same, that after 180 seconds, okay, it will consider it as a hold down timer. Okay, and then it will not try, means it will not accept any update from this network, and then after it will go for flush timer, and flush timer is 240 seconds. Okay, and after that it will remove that information from the routing table. So you can see here, if I'm coming to router 3 and I'm saying that conf t, on router 3 we can, okay, no problem, conf t interface e0 by 0 shut. So this network is down. So when this network is down, R2 will get some informations like that. See, can you see here? R3 has informed R2 that 16 hops, okay, means unreachable. Okay, now R2, see, R2 has also informed R1 about this information. Okay, so they have informed, but if they will come to check its routing table, so not here, R2, so IP route. Okay, so here you can see that they have removed the information which they have received. Okay, so like this, the update timer and hold timers are working with this. Okay, so normally what I explained you here in RIP has four type of timer: update timer, okay, invalid timer, hold down timer, and flush timer. Flush means it will wait for 240 seconds, and after that it will remove the information of that network from its routing table. It will not keep as a, like, keep holding that, okay, maybe after some time you will receive the information. Okay, so after RIP timers, uh, like, if you think that the RIP timer is like very high, okay, like hold down timer, update timer, everything is high. Like if you talk about the first one, which is update timer, is 30 seconds. Okay, invalid is 180 seconds, hold is 180 seconds, flush is 240 seconds. So it, when some network goes down, okay, see, uh, here why the conversation is very fast, because I'm using the latest version of router. Okay, so in this router, if we are talking about this one, okay, this version of the router, if I'm talking here, come here, let's stop the debugging, on all, come to router 2, on all, okay, router 3, on all. Okay, one thing before that, see here, router RIP version 2 use this multicast address 224009 to send and receive the updates. Okay, okay, now we are talking about some update timers. So if we are talking here, so version, so here I'm using 15.4 version. So in this RIP version 2 has triggered update enable, means immediately if there is any network down, immediately it informs to the routers. Okay, and immediately they converts their routing table and update their routing table. Okay, so now what I wanted to say, maybe like if we are using old version of router, okay, Okay, this is 15.4, maybe if we are using 12.4, something like that in our organization. So we want to reduce some kind of timing issues in our network. Okay, so what we can do, we can come to our router RIP and we can reduce the timing. So let me show you how we can reduce the timing. So we can come to router 1. So before I'll show you show IP protocol. So we can see here, yes, these are your default timings, right? But when we are coming here and typing conf t router RIP timers basics, okay, 5, 10, 20, 30 means 5. Now I said 5 is hold, update, invalid, hold and flush. Okay, and now if you're checking here, so IP protocols, now you see here the timings has been changed. Okay, but to make your lab identical, okay, to make your lab identical, you should enable same timings on all the routers of your organization. Okay, it doesn't mean that you enable something else on some one router 1, some different timing on router 2, so the conversation between routers will create some problems. Okay, so now what we are saying, whenever you want to remove the timer to default, so you can come here, router RIP no timer basic, simple, and then you type here so IP protocol, so IP protocol. So you can see here the timer came back to default. Okay, okay, so now we are talking about RIP passive interface. So what is RIP passive interface? See, this is very much important to know, because see, the networks is totally depending on the traffic manipulation and network smooth management. Okay, so normally whenever any interface is participating into RIP, so all the interfaces will start advertising about its status. Okay, so if you are coming here, okay, if you are coming here, suppose this is router 1, right, or router 2, router 3. So router 1, which interface is responsible to send and receive the RIP update? This interface, right? This interface is responsible for RIP update, and here this interface is responsible for RIP update. This interface, okay, let me change the color of this. Okay, delete. Okay, this one RIP update, this one RIP update and receive, and here. But this E0 by 0 interface, which is the LAN interface, those interfaces are not connected to any other router in the network. So those interfaces do not need any kind of like you can say a RIP update to receive or send, right? But if you're coming here to router 1 and if you're running this command, debug IP RIP, okay, now you will see something here. Let me show you. See, okay, so let me on all to stop and show you. See here, RIP router 1 is sending version 2 update to this multicast ID IP via this serial 2 by 0. Fine, no problem, because serial 2 by 0 we have said that okay, you can send and receive, no problem. But you can see one more option, that this your router is sending RIP version 2 update to 224.0.9 via Ethernet E0 by 0 to this IP address, right? Now when this RIP update will come to this E0 by 0, it normally it will broadcast to this, it will send to switch will start broadcasting in this, right? And switch will broadcast this RIP information in the network, then PC will discard, this will discard, but it will be there in the your switching network for some time, right? So why unnecessary you are sending the RIP update to your switching network, to your LAN? Okay, unnecessary you are utilizing the bandwidth utilization, right? So what you can do, you can simply come to your routers, okay, all routers, conf t, okay, you have to type here router RIP, you see here passive interface E0 by E0 by 0, and then and same command you can copy and paste to R2 conf t router RIP and router 3 conf t, okay, is on all. Let's stop the debugging. R2 debugging on all. R3 will come here conf t router RIP, okay, and now if we are running this debugging command now after enabling passive interface, so passive interface will help you not to send any RIP update via that interface. So you can run here debug IP RIP receive, okay, no problem, but you will see that sending, while sending you will see receiving, you are receiving only on the serial 0 by 2/0. Even if you're coming to switch router 2 debug IP RIP, okay, see, if you're talking about sending, let me on all stop it. So if I'm talking about sending one, so sending update is always via serial, no Ethernet is included now. Okay, so with the help of passive interface, when you will enable passive on the interface, so it will not send any RIP information from that link, but if any information will come to that link, it will receive, right? Okay, debug IP RIP events, let's see this one. Receiving update, sending update, okay, so it's not including E0 by 0, okay. Okay, so now what I'm saying here, that in today's lesson we completed up to RIP passive interface, and in the upcoming lessons we will be completing our remaining topics in RIP, okay, because RIP is little bit bigger than others, okay, because here we have to understand all the basic passive interface, timers, okay, manual neighbor shape, authentication, and all those things. So if you have any doubt, let me know while doing practice. Okay, thank you.